Hi guys, at this point you need to go ahead and pull out your fibers notes that you picked up when you walked in. You should be completely done with your test. You should have your fibers packet in front of you and then either a highlighter or a pen or pencil for you to underline or star whatever the important information is. So as we normally do in one of these videos, you are looking for my laser pointer on the screen. So wherever that pointer appears, that's indicating that that bit of information is important and you should be highlighting or underlining that. So again, this is what the laser looks like. Hopefully you can see it on the screen, kind of like dancing. So let's go ahead and start. So we're done with hair. We're now moving into fibers. So a couple of general things that you need to know. Fibers are considered class evidence. They do have probative value, very, very similar to hair. Because they are the exact same category. They are also class evidence, have probative value. Remember, probative value just means it's stuff that's going to stand up in court, and class evidence means that it points to a group of individuals or a group of substances or a group of organisms even, but it doesn't point to an individual person. I can't say that this specific piece of thread came off of this specific shirt. I can just say that it came off of a shirt that's similar to a shirt like this one. It's a very common bit of trace evidence that's found at crime scenes. I mean, you have fibers everywhere. Every time you touch clothing or you touch a surface, you're interacting and moving fibers around. So we find it all over the place. It can be characterized based on us looking at physical properties and also us looking at chemical properties. And in labs, we will do both. One of the main reasons that fibers are considered class evidence, and this is something I'll need you to underline, is because they are mass produced. So when shirts or blankets or any kind of material is made, it's all made in bulk in these huge factories, and they're all manufactured pretty much simultaneously, which makes it easy for different fibers to end up in different batches. I also need you to know that it is considered sensitive evidence. About 95% of all fibers will be lost from your crime scene within about 24 hours of the crime actually taking place. So it's super important that the CSI get in there and they collect and properly store this type of evidence before it gets destroyed. So while you are not necessarily familiar with fibers, you are, however, familiar with fabric. So I need you to know that fabrics are made up of fibers, and that fibers are just individual threads that are twisted together, and we call those filaments. And we'll look at a picture of what those look like in a little bit. So there are two main kinds of fibers and fabrics. You do need to know that they can either be natural or artificial. If they are natural, they come from an animal, vegetable, or some kind of inorganic source. And if they are artificial, it means that they are synthesized, made, or created from something similar to a natural source, but it's lab-based. It's something that we've created. Like the material itself is something we've created. All right, so this slide just gives you a general list of types of fibers, some random examples or general examples, sorry. So here are some synthetic ones. You are familiar with several of these, like polyester and spandex and maybe even nylon and rayon. And then under natural, we have things like cotton, which you are familiar with, silk, wool, cashmere, stuff like that. So in terms of how we put these into categories or how we classify these, let's start off by talking about natural fibers. So natural fibers are going to be classified based on their source or their origin, like what animal or what plant material they came from. Like I said before, they can be vegetable or cellulose based, they can be animal or protein based, and they can also be mineral based. And I'll give you some examples of all of them. So starting with our cellulose fiber, the most common one is cotton, and cotton is going to be a plant fiber. Okay, before I continue, for these, you need to know where they came from, so their origin or their source, and you need to be able to describe that type of fiber based on how flexible it is, how strong it is, what it does with water or liquids, how it holds its shape. So for again, cotton is going to be a plant fiber. It's fairly strong, really tough. Like if you pull on it, it's not super easy to break. It is very flexible, which means that it's very versatile. We use cotton in a lot of different fabrics. In terms of moisture absorbent, that's one of the things cotton is known for. It has the ability to absorb water from the skin very easily, which is why it normally becomes part of our clothes. and it's not very shape retentive. Now, you would know this if you have any kind of t-shirts that you've been wearing for an extended period of time. When you first bought them, they were one size, and now that you've worn them over and over again, even if you yourself haven't gained any weight, your shirt has stretched out and is now slightly bigger, or maybe even a whole lot bigger than when you first started wearing it, and it's because they don't hold their shape for a long time. Another example of a cellulose-based fiber is rayon. Now, rayon is chemically altered cellulose. So cellulose is one of the proteins that makes up plant material. To make rayon, we take that protein and we add chemicals to it to alter it. And what it does is it makes the cellulose itself really, really soft and very like luxurious and rich feeling almost. And it also makes a material that's really versatile. We can use it in a lot of different fabrics. Another example of a cellulose fiber is cellulose acetate. So cellulose acetate comes from cellulose that is chemically altered, but it makes a completely new compound that's never been found in nature. So this one, nowhere will you go and actually find this like growing out of the ground or attached to an animal. This is completely lab-based. Some examples of protein fibers. Let's start with wool. So you should be fairly familiar with wool. It's an animal fiber that comes mostly from sheep, but it can also come from several other kinds of animals, including goat. We call goat hairs mohair, by the way. Rabbit, and rabbit hair is called angora. Camel, alpaca, llama, and a couple of other animals within that family will all give you wool as well. Characteristically, it's very thick, very coarse feeling, and almost literally woolly to the texture or to the touch. Another example of a protein fiber would be silks. So silk is an insect fiber that comes from a caterpillar called a silkworm. And what the silkworm does is it makes this liquidy material inside of its body, and it spins the material around itself to create its cocoon. When that material touches the air, it hardens into these bundles or these threads of silk. The fiber itself reflects light very well. It's very shiny and luxurious to the touch, but it's also very warming. So we use it a lot in insulating heat and keeping heat trapped in. So you find it in blankets and that kind of thing. Okay, so on this slide, we look a little bit more in depth at some plant fibers. All of these are going to be natural fibers. They're natural because they come from a plant source. So like we said before, the most common one is cotton. I just kind of need you to know a couple of these examples. So I definitely need you to know cotton, and then just 2 or 3 more from this list. And you need to be able to describe them as well. Okay, so let's move on to mineral fibers. So one of the more common forms of mineral fiber is a material called asbestos. It is a natural fiber that has fire-resisting properties, so we use it in a lot of building technology and certain types of clothing. Now, in recent times, so like the last 10 to 20 years, I would say, we've discovered a link between asbestos and cancer, so it is a carcinogen, and for this reason, it's no longer used worldwide or as often as it used to be in building materials or in clothing because it has the tendency to cause cancer, but just know that it is an example of a mineral fiber. Then there's rock wool, which is another mineral fiber, but this is one that's manufactured. And then another one that you would probably be fairly familiar with is fiberglass, which is again manufactured, but this one is an inorganic fiber. So really quick, let's talk about what the word inorganic means in science. It doesn't mean without fertilizer or super expensive fruits and vegetables. Inorganic just means without carbon, like the element carbon. Okay, so if you will write that note off to the side, I really need you to remember that's what this means in this circumstance or this situation. Okay, so moving on to synthetic fibers. Synthetic fibers are for the most part made from forms or types of a material called petroleum. Not petroleum jelly, not the same thing. We'll talk about what the difference is when I return. So the more common examples would be nylon, polyester, acrylic, and spandex, and you are probably familiar with all of these. So nylon is super durable. It's the most durable, actually, of the man-made fibers, and it's very lightweight, so we use it to make clothing that we don't want to like bog us down or to hold us down. Think of like windbreaker type jackets that are really, really light and like they make that swishing noise, you know, but those are made out of nylon. Then there's polyester, and polyester is the most widely used man-made fiber, and it was made to mimic cotton. Acrylic provides a lot of warmth. It's super lightweight. It's very soft and resilient. We use it a lot in knitting type textiles. So if you have like knitted sweaters that are really, really soft and they're made out of a unnatural fiber, then it's probably made out of acrylic. The girls will be familiar with acrylic as it comes to acrylic nails and that kind of thing. It's the same substance. And then there's spandex, which is very, very elastic. It has the ability to be stretched really far distances and still maintain its original shape. Okay, and then this slide, pretty much the same things we just talked about on the one before, but it gives you like a little image to go with, and then it gives you some more information about the individual fibers. Notice with synthetic fibers, like if you look at this picture, they're really, really smooth. Like all of the units look the same, and you can tell that they all come together in exactly the same way. If we looked at natural fibers, those look a whole lot rougher. You can tell that nothing has made all of these individual pieces and pushed them together. Like this just happened naturally because they have that rough appearance. So there are several specialty fibers, but I want to touch on two of them really quick. There being Kevlar and Nomex. So Kevlar is really lightweight, very, very strong synthetic fiber. It was developed by the DuPont company in 1965. It is heat resistant and is used a lot for things like bulletproof vests and military applications. We use them in like racing tires and parts of cars or parts of machinery that will rub together and get really hot because it has that heat resistant tendency. Nomex is a type of Kevlar or a variation of Kevlar, but this one is fire resistant, so you find it in like firemen and disaster response team gear, like the clothing and the protective gear that they use tends to be made out of this material. Okay, so we're going to highlight some things on this slide. When it comes to how we put threads or fibers together to make fabrics, it really depends on the type of fabric we're ultimately trying to make. But just know that there are several ways that you can put or bond these fibers together. You can knit them, they can be woven or bonded, they can be crocheted, felted, knotted, or laminated. So these are all ways of putting individual fiber threads together to make a fabric. In modern day fabrics, most of them are either going to be woven in some form or fashion, or they're knitted in some form or fashion. And we can do the hand individual versions of these where you go in and you knit your own sweater, or we can do the mass production version where a machine actually knits all of these things together for you. Some of the things that we look at as forensic scientists, these are the things that we'll be testing when we look at these fibers in the lab, would be things like the degree of stretch. How far can I stretch the actual individual fiber or even the piece of material before it breaks or before it tears? I can test the absorbency. If I put it in a liquid, how quickly does it absorb that liquid? Does it spread throughout the entire piece of fiber or the entire piece of fabric, or does it not absorb it at all? So that leads to water repellence. If I pour water or a liquid on this piece of fabric, does it actually absorb it, or does the water bead up and roll off? How soft it is and how durable it is. How long, how much pressure can it take before it actually snaps or breaks? So all of these things are going to be individual qualities of different fabrics, and these are all things that we can look at and test in the lab. Okay, so let's talk a little bit about how we weave fibers together and the names of all of the important parts of a weave. So a yarn is a continuous strand of fiber filaments, and you can take that continuous strand and twist it together over and over again until you create a yarn. So think of one or two individual pieces, and now I've rolled those together to make a thicker piece. When you actually weave fibers together, when you actually create fabrics, there are always two sets of threads that are moving around, over, or under each other, and they are called the warp and the weft. The warp thread runs lengthwise, so from top to bottom, The weft thread runs crosswise, so from left to right. So if you look at the drawing that I've made real quick, and if you would please recreate this on your, like on the side of your notes, the long black threads are going to be your warps. Notice that they run from the top of the page to the bottom of the page. And the red threads, notice they run from the left of the page to the right of the page. Those are your wefts. So just so you know the difference between warp and weft. Then we also use the term blend to describe a fabric that's made up of at least 2 or sometimes even more different types of fibers. So for example, if your shirt says that it's a poly cotton blend, it means that it's made up of threads that are both polyester and cotton. Okay, so I know it says to draw these, but obviously you don't need to because they're right in front of you. The difference between weave patterns, or what your fabric actually looks like, is all about how you move and how you position those warp threads and those weft threads. So the ones on the screen are the 3 most common. So there's the plain weave, the satin weave, and the twill weave. We do an entire lab where you actually get to practice moving these fibers in and out to create these different shapes. So it'll make a little bit more sense when we get to lab. Okay, so again, these are explanations, like not verbal, but written explanations of the pictures that you just saw. So again, we're looking at the plain weave, the satin weave, and the twill weave. Once more, we will do this in lab, so then it'll make lots and lots of sense. But I just want to go over the examples with you real quick. So if you've ever seen a checkerboard, and I'm sure you all have, that's a good example of what a plain weave technique or a plain weave fiber would look like. Not fiber, sorry, but fabric. Everyone has jeans. What your jeans look like how those fibers fit together, that's an example of a twill weave. And a good example of a satin weave is legitimately satin. We tend to put satin fibers together in a specific way. So again, we'll do all of this in lab. So a lot of our clothing is created via knitting, where you take individual sections of thread or filaments and you lock them together, like you interlock them with a certain arrangement. And it can be made using one like super long continuous thread or a combination of individual smaller threads. Regardless of which method you use, either way your yarn is going to form like these rows of a series of loops, just loops over loops over loops, and those loops will be intertwined within each other. So if you look on your slide or even on the board, you'll see these. So they just continuously looped up and through until they're hooked together, so that way you can't easily unravel them. But a lot of fabric is created using this kind of pattern or technique, which is called a knitted fabric. Okay, so let's go back to synthetic fibers for a quick second. Synthetic fibers are made up of things or units which are called polymers, and they're just long chains of the same chemical unit repeated over and over again. So the word polymer literally means many units. Poly means many, as you know, and mer means unit or piece. So they're made up of the same type of unit or the same piece, and it's just repeated over and over and over and over again. We call all of those repeating units monomers. And because these synthetic fibers are chemical in nature, they have an actual structure. Like if you look at them up close and personal, they look different to each other. Like individual types of fibers look different to each other. So if we change the way we join them together, or we change the units that we make up, that we use to make up the polymer, then that individual fabric can have different properties and a different appearance. And we can look at these differences under the microscope. We can test these properties out chemically, and that's one of the ways that we will distinguish one fabric from another forensically. So again, you don't have to draw what you see in front of you because you have that recreated on your notes. So remember we started this off by saying that fabrics are made up of filaments or threads. Now when those threads are produced, they are kind of squeezed out of like a nozzle. Think of like making cookies or something and you're trying to get everything into a specific shape. So these filaments are done when they're hot. Like we heat them up to a higher temperature so that we can move them and make them stronger. And then we squeeze them out of these tubes until they're the length that we want them. And then we cut them off and we start making or creating our fabrics from the sections that we've just made. So because they're hot, they get slightly liquid and they will take on and keep the shape of the nozzle that they were forced or pushed through. Now the nozzles aren't always round. They have all of these different appearances, and that depends on what company's manufacturing them and what kind of nozzle they have for their equipment. So if you look on your slide, all of these different shapes are what those nozzles generally look like. So that's what your threads can also look like. So because they have all of these little nozzles that they come out from, then your fiber itself may have a unique shape, and we can use that shape to help us pinpoint what factory this particular thread could have come from. Okay, so this slide is super important. These are all of the things that we are going to question or we're trying to answer when we analyze fabrics. We're looking at what is it made of? Is this a common fiber or a rare fiber? Is this something that everyone has or something that only a couple of people have? What's the color of the fiber and does it match anything else? Was any kind of dye used on this fiber? How many fibers did I find? Where was the fiber found on my crime scene? What is the origin of this fiber? Like what fabric did it actually come from? Was it part of clothing? Was it part of a carpet? Was it part of a bag? Were there multiple fibers that got passed on from one person to the next? That's called a fiber transfer, by the way. And like maybe what kind of crime was committed and how does that fiber evidence tie into that crime? And then we also look at the time between the crime itself and the discovery of that individual fiber. Okay, so these are the more common ways that we identify our fibers through testing. Of course, we do microscope observation like you've been doing with hairs. We do what's called a burn analysis, where we literally set that piece of fabric or that fiber on fire and we make observations on how it burns, the odor or what smell we get as that fiber is burning, the color of the flame, the color of the smoke, the appearance of any residue that remains once the fiber itself has been burnt up. So we will definitely do that in lab. There's thermal decomposition, where we gently heat the fibers to break it down into its individual parts and pieces. We do a variation of that in lab. There are chemical tests, where we will take our fiber piece and we'll mix it with different acids and bases or just chemicals in general, and we look at how the fiber behaves in the presence of that chemical. There are density tests. You are familiar with density. You did this in glass, where we look at the mass of the fiber and we divide it by the volume of the object that we're putting it in. So we'd weigh the fiber, we'd put it in liquid and see how it behaves and do a calculation based on that. There's refractive index, which you also learned about when we did glass. We don't do this one in lab, but pretty much we're looking to see how light behaves as it passes through or around that particular thread or filament. And then there's the fluorescence test, where we will look to see if the fabric itself has any fluorescent properties, if it glows under a black light, for example, like you did with soil. So several fabrics get dyed before they are turned into, clothing or whatever it is that we plan on using them for. And forensically, we can look at the components of that dye and we can separate them and kind of decide whether or not our sample or our crime scene fiber matches, like the dye on the fiber matches the dye that we know companies use. So it's not the easiest thing to do because there are more than 7,000 different ways to make fabric dye. The technique that we use is called chromatography, and it's just a way to separate the dye into its different colors. And the way that a fabric either accepts or rejects a dye can kind of give us some insight as to what that fiber actually is. So some fibers absorb dyes really well, and it'll be absorbed all the way through the fibers. Others absorb it just a little bit, and the dye itself or the color itself will only be on the outside of the fiber. So we can look at things like that to kind of help us decide what type of fiber or what type of fabric this sample is. All right, so in terms of how we collect fibers, we use special vacuums, We use sticky tape. You guys are not the first ones to have invented using tape to get lint off of your pants. We do that in forensics as well. We use forceps or tweezers. We use black lights because some of the fibers do glow. And we use magnifying glasses to be able to see the smaller pieces a whole lot easier. Okay, and then this is the method that we use for the collection of fibers. So we start off by bagging clothing items individually, and we'll do that in paper bags. We make sure that we separate them based on what the items are, so that we don't place them in the same bag, and we also don't unfold them or examine them on the exact same surface before it's been bagged. Like everything is tried to be kept in isolation from anything else. Then we will take tape and we'll do what's called a tape lift, where you just take off a piece of that tape and you'll run that tape over either the clothing or the skin or an object, just wherever you think you can find fiber evidence. Once we lift fibers off of the tape, we will then take it off, literally, like pick it off of the tape using tweezers, and we will fold them in bindles and store them in a paper bag. We follow a chain of command, everything gets labeled until it ends up at the section of the lab that it needs to be at. Alright, so this is pretty much it. You are done. I will see you on Thursday, I guess, and we'll pick up from there. Bye.